Alright, so right here I set up two example problems we'll go over on how to calculate specific heat and use the specific heat equation. So you'll notice here on the side, okay, I cross this out because my handwriting's awful. These is how I always like to do equations. I'm going to redraw that. Okay. Whenever I'm given a word problem, I like to write out what I have. So I know if I'm using this equation, I'm going to have 3 out of these 4. So I'm going to have 3 out of heat change, mass, specific heat value, and change in temperature. So if we read this, calculate the heat capacity of wood if 1,500 grams of wood absorb 67,500 joules of energy. The temperature changes from 32 degrees Celsius to 57 degrees Celsius. So right here, Q, we have a Q value. We have 67,500 joules. Okay. We also have a mass. That's 1,500 grams. We also have a change in temperature. That's 32 degrees Celsius to 57 degrees Celsius. So all you have to do here to get the change in temperature is take the final temp, which is 57 degrees Celsius, and subtract 32 degrees from that, and you're going to get a change in temperature that equals 25 degrees Celsius. All right? Now, since we're missing C, we know we're solving for C, okay? And we know in order to solve for C, move this over a little bit, we need to divide Q by mass times delta T. Okay? We get that from this equation. That's the original equation. If we need to solve for C, what we're going to do is divide these, send them over there. So divide both sides by mass and change in temperature. That gets us this equation, okay? Now, it's really just plug and solve, okay? So my Q is 67,500 joules. My M, 1,500 grams. And my change in temperature, 25 degrees Celsius. Only thing you really have to worry about here is order of operation. If you'd rather do it in 2 steps, that's great. Okay, multiply 1,500 by 25, divide 67,500 by that answer. If you're putting this directly in your calculator, make sure when you hit divide, you put this whole thing in parentheses. Okay. If you don't do that, what it's going to do is it's going to divide 67,500 by 1,500 and multiply it by 25. Okay, remember we've talked about this. Your calculators aren't that smart. Okay, now your answer here, okay, is going to be, all you have to do is plug this into a calculator. It's plug and play. 1.8 joules per gram degrees Celsius. Okay, that's all you got to do. Now, second problem, okay? 100 grams of 37 degree water is cooled to 4 degrees Celsius. The specific heat needed, the specific heat of water is 4.184 joules per grams degrees Celsius. This is a reoccurring theme because we use water so much. Calculate the heat needed to do this. So, first things first, we have 100 grams, okay? We have a temperature change, and we have a specific heat value. So the mass is 100 grams. The C value, which is your specific heat, is 4.18. Let's just use 4.18 for now, okay? We'll go 4.18 joules per grams degrees Celsius. Okay, we're just rounding up to the 100th. We don't need to go that specific. And then if we take this, it's 4 degrees Celsius minus 37 degrees Celsius. Make sure you're taking, okay, the final minus the initial. Okay, it's really important you do that. Okay, because our answer here is going to be negative 33 degrees Celsius. Makes sense. You can cool things down, and that's what we're doing here. If you cool things down, the temperature change should be negative. Now, we're looking for Q, so we're just using our normal equation. Q equals mc delta T. Okay? We know mass is 100 grams. C is 4.18 joules per gram degrees Celsius. And the temperature change is negative 33 degrees Celsius. Okay, don't forget that negative sign. So our final answer is Q equals negative 1,379.4 joules. Again, it's just plugging in plugging in the information given into the equation and plugging it into your calculator. Try not to make it any harder than that. Now, on Haiku, there's that set of 8 practice problems. My suggestion would be to do that. That's where this video is posted. After that, you can move on to that mini quiz. If you have any questions or you want to go over any more problems, let me know. I'm happy to do that.